In Uruguay, protesters marched against new data centers with a clear message: it is not drought, it is plunder. In Spain, they carried banners reading, "Your cloud dries my river." This outrage is fueled by viral headlines. We are told a single chatbot query consumes an entire bottle of water, and that massive server farms are draining local municipal supplies to the point of exhaustion. Tech executives respond with their own unaudited numbers, claiming the technology uses only a teaspoon of water per search, and telling the public there is no cause for concern. The apocalyptic panic and the corporate dismissal are both based on a shallow reading of the data. Both sides obscure the reality of how computing actually works. By focusing all our energy on misleading, viral numbers, we are ignoring the irreversible damage being quietly cemented into the ground right now. To understand the water math, we have to look past the physical cooling towers people protest. Those on-site units represent only a small fraction of the total footprint. For a typical query, over 80% of the water consumed is indirect. It evaporates at the thermal power plants generating the grid's electricity, miles away from the servers themselves. This means data center water consumption is a byproduct of specific engineering decisions. The same workload can use thousands of times more water in a desert facility than it does in a zero-water, air-cooled design. In Maricopa County, Arizona, data centers account for 0.1% of daily water use. Local golf courses consume 30 times more. The data center has become a visible target, absorbing the blame for long-standing water crises like agricultural overdraft and failing infrastructure. Because water use folds back into the energy question, the conversation inevitably shifts to the grid and the fear that artificial intelligence is going to devour our power supply. But globally, data centers are responsible for less than 10% of electricity demand growth through 2030. The primary drivers are electric vehicles, air conditioning, and industrial electrification. Many of the scariest projections are based on phantom demand. Developers often file connection requests with multiple utilities at once to secure their spot in line, which artificially doubles the apparent power requirement. To find the truth, we have to sort these costs into 3 buckets. There is what is inherent to the physics of computing, there are avoidable engineering choices, and there are pre-existing policy failures. The vast majority of the environmental toll is a direct result of avoidable corporate siting decisions and broken utility regulations. The real threat is that we are rushing to build multi-decade fossil fuel infrastructure to satisfy an energy demand that utilities admit is partly speculative. Industrial order books for gas turbines are currently sold out through 2030. To meet this immediate surge in demand, the government has even issued emergency orders to stall the retirement of aging coal plants. These natural gas plants require 40 years of operation to pay off. By building them now for a temporary boom, we are locking in decades of carbon emissions that cannot be easily undone. If the projected demand fails to materialize, the central question becomes, who pays for this infrastructure? Current utility rules allow tech corporations to capture the value of AI while shifting the financial risks and construction costs onto the monthly bills of ordinary households. The primary risk of the AI boom is a regulatory failure that allows billionaires to pass their financial gambles onto the middle class. To be precise about the trade-off, we have to look at what that compute actually buys. That same power is currently delivering high-stakes breakthroughs in biology and medicine. AI-supported screening has already improved cancer detection rates in clinical trials, and in 2024, the researchers behind AlphaFold's protein mapping database were awarded the Nobel Prize in Chemistry. However, the resulting financial rewards and productivity gains are concentrating into the balance sheets of just a few megacorporations. This creates a widening global divide. Currently, over 90% of specialized AI compute is controlled by just 2 countries, leaving much of the world with no sovereignty over the technology. Progress is always a series of trade-offs. To hold this industry accountable, we have to stop fighting over cooling towers and start fighting the real battles over gas permits, grid regulation, and economic concentration.